Periodic functions are basically functions that repeat over time. So if you were to look at the graph of a periodic function, it would simply look like copies of the same function over and over and over again along the horizontal axis. So for instance, if I was to draw an example of a periodic function, it might look something like this. Maybe I have a graph that does that. Then it repeats over again. That's a periodic function because it's basically multiple copies of the same graph over and over and over again, repeating as we go to the right in x. We would say that this is the period of the function. That's the interval of x over which the function repeats itself, and that's often denoted by t. And in the box here, we give the precise mathematical definition of a periodic function. It simply says that the value of the function at x plus t is equal to the value of the function at x. What that means is that every capital T units of x, the function repeats itself. Now, you're probably familiar with several examples of periodic functions. Trigonometric functions are typically examples of these, but there are lots of functions that are not trigonometric functions that are also periodic. The life sciences are full of examples of periodic or near periodic functions because many processes of life display a periodic sort of behavior. Example 13 of section 1.1 of the textbook is one instance of that. This is an example of the temperature of a patient that is infected with the malaria pathogen Plasmodium vivax. And you can see that if you look at the temperature chart of this patient, there's a roughly 48-hour period where they have a spike in a fever and then their temperature goes back down to normal. And so the period of this function, you can see, is approximately 48 hours in this example. Now, interestingly, different malaria species display different periods in terms of the fevers that they induce, and that's one of the ways that doctors are able to diagnose what type of infection a patient has.